Can a DC ammeter or voltmeter measure AC? To answer this question, we need to understand a few basic but very important concepts: the nature of current, how meters are designed, the importance of RMS value, and how meters respond to different frequencies. First, let's talk about the nature of current. There are two main types of electrical current: DC, which stands for direct current, and AC, which stands for alternating current. Direct current flows in only one direction and maintains a constant value over time. Imagine a straight horizontal line on a graph where the vertical axis is magnitude and the horizontal axis is time. That's how DC behaves. On the other hand, alternating current continuously changes direction and its value varies in a sinusoidal or wave-like manner. The voltage and current in an AC circuit go up and down, crossing zero many times per second, depending on the frequency. For example, in India, the AC frequency is 50 Hz, which means the current changes direction 100 times every second. Now, let's understand how DC meters are designed. The most common type of DC measuring instrument is called a PMMC meter, which stands for Permanent Magnet Moving Coil Instrument. This type of meter works on the principle that when current flows through a rectangular coil placed in a magnetic field provided by a permanent magnet, a force is generated that causes the coil to rotate. This movement is transferred to a pointer that moves over a calibrated scale. Inside the meter, you will find important components like a rectangular copper coil, soft iron core, a permanent U-shaped magnet, aluminum frame, pivot and jewel bearings, and upper and lower control springs. These parts work together to detect current and display the value on the scale. The pointer moves proportionally to the current flowing in one direction, but only in one direction. So if you try to pass AC through this meter, the current constantly reverses direction, causing the pointer to oscillate back and forth rapidly. Since this vibration is too fast for the human eye to detect clearly, the meter either shows a fluctuating value or no value at all, making it completely unreliable for AC measurement. This brings us to an important point: AC measurement requires calculating the RMS value. RMS, or root mean square, is a special method used to calculate the effective value of alternating current or voltage. It tells us how much AC would produce the same heating effect as a certain amount of DC. But DC meters are not built to perform this calculation. They simply show the average or peak value of a steady current, and they are not intelligent enough to calculate RMS values automatically. In contrast, AC meters are specially designed to measure varying values and handle continuous changes in direction and amplitude. They include circuitry or design features that can measure the true RMS value of AC. Another critical factor is frequency response. AC meters take into account the frequency of the AC signal. They are tuned to measure correctly even when the current changes rapidly at 50 or 60 Hz. But DC meters completely ignore frequency. They assume that the current is steady, with no variation in time. This means that a DC meter cannot track or display meaningful results when the current changes every few milliseconds, as it does in AC circuits. Because of this, using a DC meter to measure AC is not only inaccurate, but it could also damage the meter in some cases, especially if the current or voltage is high. In summary, DC meters are designed only for fixed, steady, unidirectional current, like that from a battery or a DC power supply. They cannot correctly measure alternating current because they don't account for the direction change, cannot calculate RMS values, and are blind to signal frequency. On the other hand, AC meters are purpose-built to handle these challenges and can give reliable readings for AC signals. So, if you're working with AC circuits, always make sure to use an AC ammeter or voltmeter, never a DC one.